Most of the time, you're going to be dealing with composite indexes. That is, indexes that contain multiple columns. One of the most important things to recognize about indexes is that the order of columns in the index matter. On the slide, we have an index with 3 columns: state, last name, and first name. So it is the combination of these 3 columns that make up the index key. The order here is important though. The first column listed is state, so this is what is known as the leading edge of the index. And Oracle will only consider using this index if the leading edge of the index, in this case the state column, is included as a condition in the driving operation, whether that be a where clause or a join condition. So if we have the following SQL statement, we see that we have a where clause that contains conditions for the last name and first name, which are both columns in the index, but it does not contain a condition for the state column. And since the state column is the first column or leading edge of the index, Oracle will not consider using this index to perform this query. So how can we fix this situation? One answer is that we can include the state column in the where clause of our query. And now, since our where clause contains all of the columns in the index, Oracle will be able to use this index to perform the query. Now the issue that we have to consider though is that we may not have the state value available for us to search on. While we could write a user interface that would require the user to give us a value for the state, this wouldn't be a very usable application. Our user may only know that they're searching for Sam Harris, and they don't know what state he's from. So we need to consider some additional solutions. What we could also do is to reorder the columns that are in the index. Now the last name column is the first column in the index, so it is the leading edge of the index. Next comes first name, and finally, state has moved to the 3rd spot in the index. And so now, we have our original query again, and we have conditions in the where clause that match the first 2 columns of our index. And we can say yes, Oracle would be able to use this index to perform the query. This brings up an important point. For any composite index, your where clause does not have to contain each and every column specified in the index in order to be used. But you do want to have as many columns from the front of the index as you can in your where clause. In this example, the index contains 3 columns, and in the where clause of our query, we have the first 2 columns specified. So this index is going to be a pretty good match to run this query. Let's explore this idea further. We'll keep our same index from the last slide, so the column order is still last name, first name, and state. But we're going to change up our query slightly. Now we know that we are looking for someone with the last name Harris from the state of Colorado. So in this case, we have matching conditions for 2 columns in our index, the first and the 3rd columns, but these columns are non-consecutive. So we want to know if Oracle will be able to use this index in our query. The answer is a little bit more complicated than a simple yes or no. Since we do have a condition for the first column in our where clause, Oracle will consider using the index. What will determine if Oracle will choose to use the index is really going to be based on how selective the first column is. We're going to talk about selectivity extensively in another clip in this module, but what Oracle is going to evaluate is how many rows are eliminated by this condition on the last name. If a column is highly selective, that means that there are only a few rows which will match any value within the column, and in that case, Oracle would probably use the index. In this case, last name is probably selective enough that Oracle can use this index. So what Oracle will do is it will use the provided last name value of Harris to read all of the keys that start with Harris out of the index. And then Oracle will apply the state value of Colorado as a filter predicate to the index keys to get just the index keys and corresponding row IDs that match this condition. The application of this filter predicate occurs after the data has been read from the index though. So this is more efficient than performing a full table scan, but not as efficient as if we had a condition on the first name and could have even further reduced the number of values that we needed to read from the index. Remember though, all of this is predicated on how selective the first column in the index is. If Oracle doesn't feel that that column is selective enough, then it may decide that a full table scan is more efficient. It really just depends on the distribution of data in your database.